All right, day number 8. Let's see if we can do better today. Treetop treehouse. The previous expedition planned these trees as a reforestation effort. Now they're curious if this would be a good location for a treehouse. You need to count the number of trees that are visible from outside the grid by looking directly at a row or column. We have the height of each tree. Each tree is represented as a single digit. Tree is visible if all the other trees between it and the edge of the grid are shorter than it. Only consider trees in the same row or column. Top left 5. All these trees are visible. Okay. So then the top left 5 is visible from the left and top. The top middle 5 is visible from the top and right. How many trees are visible from outside the grid? We have 16 trees visible on the edge. Okay, whoa, that's a massive forest. Let me at least move that. Okay, so what I want to do is make sure that everything is not visible by default or visible by default. I don't know yet. What I'm thinking is that I just want to go like in every possible direction. So that would be like 0, 1. One, 0, 0, -1. But then the question is also, so what I'm thinking right now is that I want to go like have a kind of a convolution from left to right and count everything which is still visible here, which would in this case be this one, not this one, not this one, this one. Here it would be this one, no. But then here it would be this one, no, this one, no. So basically I want to go over each direction. What I probably also want to do is create this grid as like, it's visible. Is create this grid and go like just edit as coordinates. Probably this would be best. So we can say that the tree height at yx is end of the character, which gives us this nice thing. So let's maybe do one direction first, because I don't know exactly how to do it. So if I want to go from left to right, that should be easiest, right? Then we can say so go from top to bottom, left to right. Can we assume it's square? Let's do it now for now. That's probably fine. Yeah, this is exactly perfectly right. Go from top to bottom, right to left. This is pretty ugly. I'm not very happy with this. But at least what we can do is say is visible. Let's take a look at how this looks. Also in this case, we just need to start working on a smaller test case again, because this of course would be terrible. So now we can at least see 0, 1. Oh, what? We can see everything. That's not meant to be. Oh, that's not true, by the way. 0, 0, 1, 0, 2, 0, 3, 0, 4. Yeah, so we cannot see 1 tree at the moment. Okay, so that's perfect. I'm still not happy with this, because I want to generalize it. So in this case, we say so we can say maybe what's the start y, start x, delta y, delta x. And then we get the max length, and we of course get is we are in Jupyter Notebook, and this is F code, no need to do anything fancy. This is actually better than I expected, because this is indeed exactly what I need. The problem is now that, so I can go from top to bottom, left to right, but I'm always first starting at the top and not going at the bottom. Okay, let's maybe just do this by hand for now. So then we go over x, starts at 0, and then we continue. Later we go from top to bottom, left to right, normal like that. Go from top to bottom, right to left. Then we go from left to right, top to bottom. Yeah, it doesn't matter which order. As long as I go from right to left, it's fine. So in the example, there were 18, right? Nope. Nope. Absolutely not. So the top left one is visible from left and top. Visible from the top and right. So to get this clear, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22, 22, instead of the 21. So something there is also wrong. But what did I personally just do? I just scan everything like this and say, okay, what is the maximum height so far? Trees around the edge are visible. Okay, so far this has been me rambling for 15 minutes. Let me just take a look at this again and see how this looks so far, and maybe we can then generalize it. So at the moment it says that 0, 1 is visible, and that's not true. Okay. Yeah. At least this will make it easier for me to debug this visually. Yeah, okay. So here I can say start y, start x 0, 0, end y, end x is then lines. Yeah, perfect. Delta x, delta y, delta x is 1, 1. Perfect. In start x, start y, end y, delta y, start x, end x, delta x. Cool. This, what we're going to do now, is ugly because we parameterized it and then we're going to copy paste anyway. So we went from top to bottom. Let's go right to left. And so then start x is then lines -1. If you want to impress your manager, you of course have to copy paste more codes. And you have more lines of code to commit. He's still using for loops. Okay, so we have bottom to top, which and then 0 left to right. So then we start at then lines -1, and then the end of y is -1. Okay. And then we still go from bottom to top. But this time everything is -1. Okay, delta x. Yeah. Okay, this is such a hot mess. Okay. So the one thing I need to change here is that when I go, that I want to go from left to right, top to bottom. That's the difference. Okay, so I have vertical sweeps and horizontal sweeps. I shouldn't do this. Yeah, okay, got it. So then I have from left to right, let's just say top to bottom. Then this start y is still 0. Yeah, okay. Okay, so we got horizontal sweeps and vertical sweeps. I guess that's the thing. Vertical sweep, left to right, vertical sweep. Actually, these are the horizontal sweeps. Vertical sweep and vertical sweep. Top to bottom, bottom to top. So then we have top to bottom, so start X starts at, yeah, okay. I know I keep saying this all the time, but this time I'm relatively confident that we have got the right thing. So we got, what does it say? There's 21 trees visible and that I have 19. Let's just define this as a function. That way we can at least test that. And see what is going on. Okay, so what is going wrong at the moment? So 0, 0 is visible, 0, 1, 2, 3, 4. That's all right, because I 1, 2, 3. Oh, that's funky. So 1, 0 should be visible as well, right? Because it's on Y1 and 0. I think I got it. This is wrong. It starts, of course, as -1, otherwise you cannot see those things. Wait a second. Yeah, okay, so now we see 21. Oh, okay, that was a dumb mistake. That was a pretty dumb mistake. But hopefully this is correct. That is the right answer after only half an hour. But do some quick crypto mining, I guess. Content with the amount of trees cover is available. The officers need to know the best spot to build a tree house. They would like to be able to see a lot of trees. About distance trees, taller than those found by the rows above. Looking up, the view is not blocked, it can see one tree. Looking right, its view is blocked immediately. Oh, looking left. The scenic score is found by multiplying together its viewing distances. Oh, it's very wholesome. Oh. Let's go back to our example. Okay, so we need to check let's do it here. What we can do is, of course, change this function and say 0 this is 1 return visible, and do the same with our nice horizontal sweep function. Yeah. Because then we can reuse some code. Because then we can just say, let's copy paste this thing. Okay, so we want to find the best scenic score. Let's just set it to 0. At let's say y plus 1 x height width is landlines. Okay. That makes typing a bit faster. So if we want to check, let's first go spot to right. So we start in the same height, we start at X, and we go to the right, so then we go up to the width of this thing. And then the delta Y is 1, I guess, and the delta X is 1. But now we also go back to -1. Yeah. So we also go from there to the bottom. Oh yeah, okay. We need to multiply instead of adding. So we said that the best scenic score would be okay. So we had one example here at 1, 2, 3. X is 2. So why does it say here it's 2? Luckily we can debug this. So this is going from the top or from left to right. You can see 2 trees. Yeah. And looking left, you should be able to see 1 tree. Wait a second. So it says that horizontals. Oh. Okay. So there it can see 1 tree. Wait, looking right, it should be able to see 2 trees, right? Not 1 tree. One, 2. Yeah. So what's going on with my horizontal sweeping? guess this is also wrong. Let's just make a new thing called visible horizontal. And then for x in because it can only look down, right? So the max height should start at a tree height. That's what I was doing normally with sweeping. I was still checking for the max heights instead of the minimum heights. Yeah, okay, that was what I was doing wrong. At least I realized, why are these puzzles at 6 in the morning? Okay, so now we have a visible horizontal. So it sees one tree when going to the right. But why? So it is at first at index 3. Sorry, let me just also add a y. I know it's not changing, but otherwise it's confusing. So first it's a 1 tree. 0, 1, 2, 3. Why does it say the tree height is 3? And 5. This doesn't make sense. This is so not right. Zero, 5, 5, 3, 5, 3. Okay. Wait, am I now confusing y and x? Okay. Welcome to person who works with matrices like this all day still makes mistakes. 25512. 12. And then we have visible horizontal on y-x. So we have 3, 4, 1, 2. Yeah. So we go down. Perfect if the tree height is smaller than the max height. Y minus 1. This is also not correct, so I have to visible because I need to multiply these numbers at the end. So the visible on the right is like that, visible left. Let's try that again. Yeah, okay. So this is visible down, this is visible up, visible up, visible down. Vertical. We're already approaching the 44 minutes. And I feel like my code is extremely terribly ugly today. Up, down. Yeah, now we got to multiply the scenic score. That's 24. Now the question is, where are my printing things? Go. At y. So at y, it sets it at y2, x0. I mean, this thing is high. This tree is amazing. Great tree, amazing tree. Great place for a tree house. So then up I should be able to see 1, 2 things, not 1. Down I should be able to see 2. Okay, so I see multiple bugs. This is 1. The height has to reset, of course, every time. We had a great test case here with okay, so up still says 2. That's not good. Let's debug that first. Oh. Ah, this is such a terrible morning. It doesn't really matter, but here if we are overwriting this, then of course it goes wrong. Okay, so here we can see, here we can see 2 to the top, 2 down, 0 to the left, 4 to the right. Let's take the scenic score of this example. So there we had y is 1. So then we can see 1 up, 1 down, 0 to the left, 2 to the right, One issue I have with my code right now is that I'm not taking into consideration as soon as something blocks, you still see the tree, you just stop looking. So this is still not correct. So, so now if I look up, I see 1 tree. If I look down, I see 1, 2 trees. If I look left, I see 1 tree. If I look right, I see 1, 2 trees for a total score of 4. And then we had the other example at y 0, 1, 2, 3. X is 0, 1, 2. Seeing score of 8. Those 2 amazing test cases are passing. The best scenic score is 8. So if we take that, then we get a massive, amazing scenic score. Oh yeah. Let's take a look at how other people did today. Looks like Alexander already completed it. Alex is pretty good, but Michael is also still struggling apparently. One thing which is fun, by the way, so this took me 55 minutes, I'll still take 1 more minute here, is that yesterday I actually tried this again with big struggle I had for day number 7. So the parsing function is relatively the same, except for that I don't need to keep track of the entire folder structure. But the only thing I do is that I take all the files and create one big massive list with all the files. And then to calculate the size of each folder, you just go from the root to all the child folders. And then you know exactly how much each folder contains, because you only keep track of files. You don't even keep track of the folders and how much they normally contain. And that makes it relatively simple, because you can just loop over all your directories once and then see how much they contain. And then you're done relatively fast. Had I only thought of that yesterday, I would have been a way happier man. Anyways, that's it. Hope you have a good morning. See you tomorrow.